Hey everyone, how's it going? My name is Ian, and in today's tutorial, I'm going to be teaching you all about the OpenAI API and how we can interact with it using the Python programming language. So in this video, we're going to specifically focus on interacting with the chat completions API from OpenAI, which essentially allows us to engage with a GPT model like GPT 3.5 Turbo or GPT-4 in a conversational format. So this is something that you're probably already familiar with regards to using tools like ChatGPT. This is essentially what's happening behind the scenes, and now we're going to use a programming language like Python to have more granular control and programmatic control of how we interact with that API. So instead of just typing information into a graphical user interface, we're actually going to write the code to send these questions to the model and get back responses. So learning the skill can be super useful, especially if you're interested in like building chatbots, image generators, recommendation engines, code review tools. There's just so many options. In fact, if you ever wanted to see kind of what kind of projects are out there, you might go check out there's an AI for that.com. They have a whole host of different projects that people have built using these kinds of tools. So you can kind of see what some of the possibilities are and spark your creativity in that way. So this video is actually the first in a larger series where we'll continue to introduce to you the ins and outs of using OpenAI, its API, as well as the Anthropic API and the prompt layer APIs. So this series is really great for anyone who's interested in prompt engineering as a whole. And so if you think that's you, then definitely stick around because I think we're going to have some content here that you'll really enjoy and be able to learn from. So before we get started, if you want access to the GitHub repo, the code that I'll be using in this video and the videos that follow, be sure and get that link from the description below. You can clone or download that repository onto your local environment and follow along with the videos that way. So yeah, without further ado, let's go ahead and get into the code. Okay, so I'm working inside of Visual Studio Code. Which editor you use does not matter. You just need an environment where you can write some Python code and a terminal to be able to run that code. So the first thing I'm going to do up here at the top of my program is introduce some boilerplate code. And I've got a couple modules that I need access to in order to make this program work. Before we talk about that, let's talk about what this program is going to do. Essentially, we are going to send a request to OpenAI's chat completion API, and we're going to create a new chat completion object. So that is essentially what happened when you're using a tool like ChatGPT and you type in a query or a prompt, and then you get back a response. So this is what's happening behind the scenes. We're going to actually do this programmatically using this API, using Python. So we're going to tell it which model we want to use. We're going to create kind of a history of the conversation. We're going to set the tone of the conversation. We're going to determine how variable it is, how creative it is, or how concise it is with its responses. And we're also going to dictate the max number of tokens. We'll talk more about what some of those terms mean here in a second. But essentially, once we run this, we're going to get an answer back from the API to our question, which is which NHL team plays in Pittsburgh. So down here at the bottom, we can see an example response where it comes back to us and it says the NHL team that plays in Pittsburgh is the Pittsburgh Penguins. But that's not all it gives us. It gives us a whole bunch of other information that can be really useful when we're creating larger applications around this technology. So let's back up to the very beginning now that we've done kind of an overview of what it is we're building, and let's start getting into the actual syntax. So at the top here, on the first line, I'm importing the OS module. We need that because we're going to export a environment variable for the OpenAI API key, which you'll need to get from the OpenAI API. So you might want to pause the video, or after you're done watching the video, go to OpenAI's website, go find their API link. We can put that in the description, of course, and sign up for an account if you don't already have one. Set up your billing, buy some credits. You can spend as little or as much as you want. Based on how many tokens you'll think you'll need, and we'll talk about what tokens are and how they work here in a second. But once you do that in your settings, you can generate a API key, which you can then export as an environment variable, and you're going to want to name it OpenAI underscore API underscore key if you're going to be using this code from the repo. You can name it whatever you want if you're just following along and you want to use a different value for that environment variable. All right, so then the next line, the kind of meat and potatoes of this entire program, is importing the OpenAI module. Without that, we cannot interact with OpenAI's APIs. in this case, the chat completion API, so we got to have that one. Now, the first thing we do on line 4 after importing those modules is we set the API key property or attribute equal to the result of doing a os.getEnv on that environment variable that we set. Okay, so that's going to set up your API key on OpenAI's API, and now you're able to send and receive request response from that API. So let's look at this doc string here. It's going to outline exactly what's happening inside of the code that follows. So in the code, we have a model argument, a messages argument, a temperature argument, and a max tokens argument. These are not all of the parameters that can be used with the chat completion API's create method. These are just the bare minimum that we need to get a response back, an answer to a question that we're going to ask. So let's talk about what each of those do, starting with the model. So the model is an ID of the model to use, and we've got some links here. You can go to the documentation, and you can see which models are available to you. Essentially, there's GPT 3.5 Turbo, and there's GPT-4. GPT-4 is more creative and more powerful in many ways, but it also comes with additional cost in terms of the tokens and then the credits that represent those tokens. You can see what those costs are by visiting OpenAI's pricing page, and you can determine which one you should use based on that. The next argument is messages. So messages is going to be a list of messages comprising the conversation so far. So you can think of this as the context. We can start with our initial question, and that's fine. The GPT API can take that and it can answer it for us. But then if it doesn't have a history of the conversation that we've had, and we have a follow-up question that doesn't have any context to support it, then it's not going to know the best way to answer that follow-up question. So by creating this list of messages in a ordered format, the API can go back and look at the history of our conversation thus far to determine the context of whatever the current question is. That way it can give us the best possible answer, and that allows us to have this continual back and forth chat type conversation. So after that, we've got temperature. So temperature is going to be the argument for the sampling temperature that we want to use. The values are between 0 and 2. Higher values like 0.8 or even 1 or 1.2 will make the output more random, and it'll make it more creative. Lower values closer to 0 are going to make it more focused and deterministic. So essentially, if you need something to be very concise and technical, then you might want to keep that value lower. But if you want to give the API some more creative freedom, then you might want to make it a little bit higher. It just depends. You can keep changing it and tweaking it until you get it right where you need it to be, based on a number of responses that you can look at. So then max tokens here at the bottom is going to be the maximum number of tokens to generate in the chat completion. After we're done looking at the code, I'm going to pull up a couple pages and show you exactly how tokens are created from the text that we use in our prompts and from the text that is given back to us as a response to our prompts. But essentially, you can think of tokens as the measurement of the inputs and outputs to this API. So if we're sending a request with some text, something like which NHL team plays in Pittsburgh, then most roughly four letter words are going to comprise one token. When you get to larger words like Pittsburgh, then it's going to start breaking it up into multiple tokens. Okay. So this word right here, it might just be one token. It might break it up into two tokens. And then the space leading to the next word, including the next word, in this case, a 3-letter word, NHL, will be our next token. So this is roughly 2 tokens. And then the space before the next word with the next 4 characters is going to be the next token. It's going to repeat that pattern until it gets to a word that has multiple, more than 4, essentially maybe like 7 or more characters. And then it's going to break it up into multiple tokens. And so the output to our request will actually tell us exactly how many tokens were used for that request. So that's going to include everything that we piped in plus whatever we're getting back. So we'll see that more in a minute. In any event, because all of this isn't free and it costs money, and because these GPT models actually have token limits, you want to set a max tokens value so that you can dictate exactly how many of your tokens are being used, or like what the maximum amount of tokens can be used before you max out your limits. That way you don't spend too much money and you don't surpass whatever the predefined limits are for the models. Again, the link up top that we looked at a moment ago for the models is going to have more information about how many tokens are required or what the maximum tokens are for any one of these models that are listed there. All right, so down here in this other doc string, and when I say doc string, if you're not familiar with those, they're just multi-line comments with information about the program. And so this is an example of the response data. It has our chat completion object. Remember, we are accessing the chat completion API. And so if you want to learn more about all of the different fields that are included in this object, you can visit this link right here. But let's just do a brief overview of everything that we're looking at here. So this is an example of what we would get back from executing our code right here. So this would be the response variable pointing to the response from this API call. So down here we have an ID. That's just a unique ID representing this particular chat completion object that we're getting back. And then what type of object it is, this is always going to be chat.completion when dealing with the chat completion API. Created is just a Unix timestamp in seconds. The model is which model we used. Up above, we used 3.5. For this particular example, it was using GPT-4. So it's just telling you, hey, GPT-4, but it has some additional numbering with regards to the current version that was used. These models are changed over time, and so they have varying versions, and they track those with these additional numbers. We have choices here. Choices is a list of multiple objects or dictionaries. When we made the request, we did not add an additional parameter indicating that we wanted multiple choices. We could using a parameter called in. We can talk more about that in future videos, but by default, you only get back one choice if you don't indicate something other than in is equal to 1. Or if you just omit in altogether, then you get one choice back. So that's what we have here. We have one choice inside this list. It has an index indicating its order and all the choices if there were more than one. And then it has a message object or a key that points to an object, or what we can also call a dictionary, that indicates the role of the message. So who is it that is giving this message? In this case, it's the assistant. And in the context of the OpenAI API, especially with regards to chat completions, we have 3 different roles. We have the system, we have the assistant, and we have the user. So we'll talk more about those as we execute our code here in a moment. But this one is from the assistant, which is essentially the part of the API that has the back and forth conversation with us. So the content is the actual textual content that is a response to our initial question or our follow-up question if we're having a continued conversation. So in this case, the content says the NHL team that plays in Pittsburgh is the Pittsburgh Penguins. The last thing that we're going to see with regards to the choice object is the finish reason. In this case, it's stop. There are multiple values that can go inside of the value here for the finish reason key. Stop is a good one to see because it lets us know that it did not stop because of like our max token limit or anything like that. It stopped because it reached a natural stopping point. It's essentially, if you're thinking about like status codes, it's kind of like the 200 of status codes. It's just saying, hey, everything worked properly and we stopped naturally. There was no errors or there was no limits that were reached or anything like that. The last thing down here outside of the choices list is the usage key that points to another dictionary object where we have prompt tokens and completion tokens. So prompt tokens are our prompts, right, that we inputted, and then completion tokens are for the completion object that was generated back to us. And so 24 plus 12 is 36. So total tokens is going to be the combination of the prompt and completion tokens. This is useful because as you're creating these prompts, you can start seeing how much the usage is, and then you can determine, okay, if I did this X number of times, it would cost me this many tokens. That would, essentially be this much money, and that's how much this type of program would cost to run over, some time span. So it gives you an idea during development what your usage looks like. You can also go to the OpenAI dashboard, same place where you'll have generated your API key and set up your billing. There's going to be a usage button in there. You can take a look at a graph that shows you your usage day by day. So that's helpful as well. So at the bottom here, we have a print statement where we pass in our response variable. We have an empty print just to give us some nice formatting with that output. And then we have an additional print where we actually traverse down through that dictionary, looking at the choices list, the first element inside of it with the 0th index, and then the message attribute with the content attribute from there, which ultimately traverses all the way down to this string value. And that's what will get printed to the console here. So we can actually run this. Let me move my little video out of the way and run this Python file. You can actually see where my previous run is in the history of my terminal. But it does take a second or two to run, right? This is an API call, and that means that there's the time, the latency between our requests, what happens out there on the OpenAI server, and it coming back to us. But in addition to that, we're dealing with a GPT model that it has to take a little time to process all this information. So it does take a second or two, and there are ways to increase the user experience or make the user experience a little bit better whenever you're building applications around this sort of thing. You can think like when you're using ChatGPT and you type in a question, it might give you like a little loading wheel or a ... sort of thing. And then when it actually starts giving you the output back, it does it kind of like typing out on the screen as opposed to just dumping it all at once. So those are the types of things you can think about once you get to the UI UX part of developing your applications. For now, of course, we're just kind of waiting. We know it's going to give us a response of some sort. And then after a second or two, we get back our response. So let's take a look at what we got back here. We can see that this is very similar to what we were just looking at with that doc string where we had some example output. So it's going to have the ID, the object, the created timestamp, the model. In this case, because we use GPT 3.5 Turbo, it's going to say that that's the one that we used, and then it has the versioning at the end there. The choices, again, because we didn't pass in any in argument to determine that there would be more than one choice, then it defaults to 1. So we get one object inside of here. Its index, of course, is 0. It is the first element inside of this list. It has a message which points to another dictionary or object where the role is assistant, and the assistant is responding to our question with the content. The NHL team that plays in Pittsburgh is the Pittsburgh Penguins. This is actually the same exact response to the initial, the example output, I should say. And that's because we have a pretty low temperature, right? So again, if the temperature value is low, closer to 0, then you're going to get more consistent responses. Not a lot of variation. And as you go higher, closer to 1 or even 2, then you're going to get more variation, more creativity. All right, so the finished reason is stop. That's good. That's what we're looking for. And then the usage here is actually the same as the example that we saw in our doc string, where we have a total of 36 tokens. Awesome. So let's pull this down a little bit and go back and look at our code. One thing that I want to address a little more here is the role of the messages list, okay? So, or the role of the roles of the messages list. We're gonna talk about the roles for each of these messages. How about that? So the first message that we have here, the first object representing a message in our messages list has a role key. And you'll notice both of these objects have that, and even in our response, we have that. So the role for the initial one is system. And like I said before, there are 3, right? There is the, what do they call it? The assistant. And then we have the system, we have the user. So the system is only ever going to happen once at the very beginning. This is us kind of providing the tone or maybe the context for the assistant's future responses. We're saying, hey, you, the system, you are a, and then some sort of something that they are. So in this case, we're saying you're a helpful assistant. Just so you know, if you were to omit this, by default, it's essentially going to be a helpful assistant. That's kind of GPT 3.5, GPT 4's like default mode. But if you want to modify it to where like you are a expert in the field of some sort of science or mathematics, then you can do that. And it'll give you answers. It'll do its best to form its answers in such a way that would respond to you as if it was that role. So here we're just saying you are a helpful assistant. That's great. You can mess around with this and set the mode, or set the mood rather, set the tone for the assistant by modifying the value to the content key inside of this object. So the next one in line is the role for the user. This is our initial question. This is like what you would type into the input on ChatGPT, the actual website. So we're saying, hey, here's our initial question. Which NHL team plays in Pittsburgh? And what we get back, of course, is going to be from the assistant. So if we go down here to the response, you can see that the message that comes back has a role of assistant, and then the content is what the answer is to our question. And so this is useful because then we can take that object and push it into or append it to the end of our messages list and include that in our next request back to the API if we have a follow-up question as the user role. So what'll happen is we're creating this history of the conversation between the user and the assistant, of course, with the initial setup as the system. And then every additional request we make to the API will have that context and be able to answer us more efficiently and effectively. So that is more or less it. I'm going to pull up a couple more pages here to introduce you to a few more things I think are really useful before we wrap up this tutorial. So let me jump over here to this browser window where I've got a couple different pages for the API itself that are open. Okay, so this one is for the chat completions API. If you want to dive a little bit deeper or you want a different perspective on everything you've learned in today's video, this is a great place to start. You're going to read through what it tells you. It's going to have examples. You can change it to a different language if you prefer something like Node.js to Python, and you can see the code for that. And you can see some example results and how to traverse through those objects to get whatever it is you're looking for. In this case, the content. It's going to give you information about all the various parts of the response object and so on. So this is helpful as review. And if you want to dive a little bit deeper, of course, you have access to way more than what we talked about in this tutorial. So this is a good place to bookmark and come back to as needed. Meanwhile, over here, we have access to the playground. By the way, all the links to these will be included in the description of this video. But this is the playground where, let's just say you're in an environment where you don't have immediate access to Node.js or Python to be able to run this code in a editor or some type of IDE, no problem. You can still experiment with this if you have an API key set up. You can go to the playground here. You can tell the system what the system is. That's that 0th message in that messages list. And then you can start with your user role content just by adding a message here. And then you'll start getting responses back from the assistant role after you submit the user's message. So then you can modify the mode, whether it's a chat, and then there's a couple other legacy options here that you can look into. The model that you want, we have things like 3.5 Turbo, which is what we used in our code example, or we have GPT-4, GPT 3.5 Turbo 16K. You can learn more about what that is from the documentation, or that you have even more models than that you can access. Just a reminder there, GPT-4 will charge you more tokens per request. So you want to make sure that you're familiar with the pricing structure and everything. And again, we've linked to the pricing earlier in the tutorial. You'll have that in the description of this video as well. But you can see here, you can modify things like the maximum length, which is your tokens, and the temperature. And there's some other things in here that we didn't talk about that you're feel free to mess around with. These are some of the parameters that are not essentially required, but can give you a little more control as needed. So then the last thing I have here is this tokenizer page, which I want to show you all because we talked about tokens and I kind of briefly explained that one token is roughly 4 characters of text in the common English language or common English text. And so they translate to roughly 3/4 of a word. So like, let's say you have 100 tokens, that's around 75 words. But if you wanted a nice visualization of how this actually works, then I want to show that to you here. So if I click on show example here on this tokenizer page, it's going to give me some text. It even gives me an emoji and it gives me some numbers, things like that. And you can see here how many tokens it pulled from this text, or how many tokens this text is equal to, and then how many characters were in the text overall. And you can see with this color highlighting how exactly it breaks it up. So for example, a word like emojis is M and then oj and then e's, or Unicode is un and then ic and then ode. But there's some other words that are long that still equal 1 token, like underline. The exact science isn't necessarily 4 characters, but that's just kind of the average that you can round it down to. But if you want to get more of an understanding of kind of how this process works, you can look. You also notice that some of these these tokens are broken up by like common patterns. So for example, 123 is a common pattern. So out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 0, it broke up 1, 2, 3 into its own token, and then 4, 5, and then 6, 7, 8, and then 9, 0. So you can look at the token IDs and you can see that essentially if there's two matching tokens, they have the same token ID. But each one of these tokens is given its own ID. We're going to talk a lot more about this more advanced stuff in future videos, but for now, this is just a good introduction to kind of what's happening behind the scenes, what a token is, and kind of how it's used as a measurement of your requests and the response that come back to you from the API. So with that said, thanks for watching this video. If you have any questions, please feel free to ask them in the comments below. Check the description out for all the resources, the links to the repo for this series, and be sure and be on the lookout for the next video in the series coming soon. Thanks a lot, and we'll catch you all in the next video.